Welcome to lecture number 92 of digital electronics. In this lecture, what we are going to do is we are going to convert JK flip-flop to SR flip-flop, JK flip-flop to D flip-flop, JK flip-flop to D flip-flop. So here the base flip-flop what we are having is JK flip-flop. So JK needs to be converted to D, JK needs to be converted to T, and JK needs to be converted to SR. Okay. So the base flip-flop is JK. So first one I am going to deal with is conversion of JK flip-flop to SR flip-flop. Or we can write realization of SR flip-flop using JK flip-flop. Realization of SR flip-flop using JK flip-flop. So what we have is JK flip-flop. So what you required is SR flip-flop. Okay. So in the previous lectures what we have done, what we are having is SR, and what you require is this one, right? So if you are having J and K, so you should write J as a function of S, Qn and Qn bar. Also K as a function of S or S R Qn Qn bar, whatever it is. And K as a function of S R Qn bar. Okay, because we are having inputs as S and R, and having inputs as S and R. Inputs are S and R, and that inputs should come inside the function. For that, first I am drawing the truth table of SR, and after that we will write the excitation table of JK. So first we will do with the truth table of SR. Yeah. So I am having S, R, and Qn. So I am going with the truth table of S, R, and Qn. So here what we have is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Okay. So only this much is what we are having. And for this S and R don't care, nothing is there. So here what we are having is here Qn plus 1, that is next state. Okay. So this is present state and this is next state. It is set and reset is 0. Next state is, and after that what we are having is J and K. Okay. Present state is 0. Set and reset is 0. That means it is 0. S and R is 0. 1 means the next state is it will remain there. So 1 means it is resetted. 0 to be resetted. 0, 1 it is resetted. 1 is resetted to 0. Now here what happens? 1, 0. That is it is set. 1, 0. It is set. Then if S and R is equal to 1. If S and R both are equal to 1, nothing is there. Okay, if S and R is equal to 1, we cannot predict what is output. So we can take it as don't care, or we can discard these two states. Okay, because we cannot predict the next state. Okay, so we can discard that, or we can make it as don't care. Now, if this is the case, yeah, if you are coming into the excitation table of JK, if it is 0 to 0, if it is 0 to 0 means it is 0 don't care, and 1 to 1 means it is don't care 1. Yeah, 1 to 1 means it is yeah, it is 0 to 0 means 0 don't care. 1 to 1 means it is don't care 0. Yeah. So 1 to 1 don't care 0. 0 to 0. 0 to 0 means 0 don't care. 0 don't care. 1 to 0 means it is 1 to 0 means it is reset. That means K is 1, right? K is 1 and J is don't care. And here what happens, Qn and Qn plus 1. So here what we get, it is set. So it is 1 don't care. So where we have done with the excitation table of Jk, we will go back to the excitation table of Jk. In Jk flip-flop, wait. Yeah, this is the excitation table of Jk flip-flop. Yeah. If it is 0 to 0, it is 0 don't care. 0 to 1 means 1 don't care. 1 to 0 means don't care 1. 1 to 1 means don't care 0. Okay. So this is the basic excitation table of Jk flip-flop that we have dealt in the previous lectures. And coming back to our lecture. Yeah. So it is 1 to 0 means don't care 1. Yeah, that is it. Okay. Now we need to write expression for J and K in terms of SR and Qn. Okay, because here we have no need to consider these two states because there is nothing like don't care in the next state of J and K. So we can consider that that also as don't care, no issues. Now coming into the K map, that means you need to write J as a function of S, R and Qn, and K as a function of S, R and Qn. That is the basic requirement what we have. Now coming into the representation, so this is 0 up to Qn. So it is 0, 1, 2, 3, 4, 5. If it is 6 and 7, if it is 6 and 7, you will consider it as don't care. So I am going to draw with J and draw the K map of J. I'm going to find the expression for J. So here I am having SR, Qn, 1, 2, 3, 0, 0, 0, 1, 1, 1, 1, 0. So this is 0, 1. So this is 0, 1, 2, 3, 4, 5, 6, and 7. For 0, it is 0. For 0, 1, don't care. 2, 3, 0, don't care. 2, 3, 0, don't care. 4, 5, 1, don't care. 4, 5 is 1, don't care. And 6 and 7, no need to care that. So we can make it as don't care. So this is S bar R bar. This is S bar R, S R, S R bar. This is Qn bar, Qn. Now we can club in the form of a quad. If I am clubbing if I am forming a quad, I can form the quad here, right? So here what is common? Here what is common is S is common and nothing else is common. So we can write J is equal to S. You can write J is equal to S. Now coming into K, coming into the K map of K. And then draw the K map of K. So it is, I need to find the expression for K. That K is in terms of S, R and Qn. 0, 1, this is 0, 0, 0, 1, 1, 1 and 1, 0. This is S bar, R bar, S bar, R, S, R, S, R bar. Qn bar, Qn. 0, 1, 2, 3, 4, 5, 6 and 7. Now coming into the values for 0, 1, 2, 3, it is don't care, 0, don't care. Don't care, 0, don't care. 3 is 1. 4 is don't care. 5 is 0. 6 and 7 are don't care. Therefore we can take a quad. Here we can take a quad like this. So what is common? Only R is common. So what we can write? Here K is equal to R. Okay. So J is equal to S and K is equal to R is the required expression. So here what you are having is you are having a JK flip-flop. you are having a J, K flip-flop. Okay, of course there is a clock there. And what is J? J is equal to S and K is equal to R. Nothing else is there. So you can having Qn and Qn bar as output. So this is basically a JK flip-flop. Okay. So now I have converted this JK to the SR flip-flop. Okay. So this is basically when J is equal to S and R is equal to K, you can say that JK flip-flop acts as SR flip-flop itself. And next one is conversion of JK flip-flop to T flip-flop, or we can write realization of T flip-flop using JK flip-flop. Realization of T flip-flop using JK flip-flop. Okay, you can take it in any pattern. Now, here what you have is JK flip-flop. What you require is T flip-flop. So what you need to write? You need to write J and K as a function of T and Qn. Right? J and K as a function of T and Qn. So first of all, let me draw this T and Qn. Then I will write Qn plus 1. That is next state. This is present state. Next state. After that we will go with J and K. This is J and K. Yeah. So it is 0, 0, 0, 1, 1, 0, 1, 1. So since it is only two variables. Now if it is 0, if toggle is 0 means present state is equal to next state. 0 means 1 becomes 1. Here 1. So 0 becomes 1. 1 means 1 becomes 0. Now what are the values of J and K? If it is 0 to 0. 0 to 0 means it is 0, don't care. 1 to 1 means it is don't care, 0. 0 to 1 means it is set, so it is 1, don't care. 1 to 0 means it is reset, that is don't care, 1. Okay, so that is the excitation table of JK flip-flop, right? Yeah, that is excitation table of JK flip-flop. That is basically the excitation table of JK flip-flop. Zero to 1. 0 to 1 is 1, don't care, and 1 to 1 is just don't care 1. 0, don't care, 0, 1, don't care, and don't care 1. Okay. Now, coming into the expression of J and K. So I need to write J and K as a function of T and Qn. So coming into a two variable K map. Okay. So I will write this one, the decimals as 0, 1, 2, and 3. So T and Qn. Coming into this is T, this is Qn. And I am going to write the expression for J. So this is 0, 1, 0, 1. T bar, T, Qn bar, Qn. 0, 1, 2, and 3. It is, it is 0, don't care, 1, don't care. 0, don't care, 1, don't care. So here what we can have, here we can club these two. So what is the expression? Here we can get J is equal to T. You can get J is equal to T. Now I am going to derive the expression for K. Right. So I am having T and Q and again. T and Q and this is 0, 1, 0, 1, T bar, T, Qn bar, Qn. This 0, 1, 2, 3. That is don't care 0, don't care 1. It's don't care 0, don't care 1. So here what you can have, you can club these two. If you are clubbing these two, again what will you get? You will get K is equal to D. That means for JK flip-flop to act as T flip-flop, you should write J is equal to K is equal to T. So if you are drawing the block diagram, what you are having is, what we have is JK flip-flop. We are having JK flip-flop along with the clock, and you need to sort this J and K. T is there, and this is K. Here we will get Qn and Qn. Okay. This is how we are converting JK to T flip-flop. So we are converting JK to T flip-flop. Now the last one in the conversion of JK, last one is conversion of JK to D flip-flop. Okay. Or we can write realization of D flip-flop using JK flip-flop. Okay. So what we have is JK flip-flop, and what you require is D flip-flop. So you should write J in terms of J and K in terms as a function of D and Qn and Qn bar, whatever it is. Okay. J and K as a function of J and K as a function of D, Qn and Qn bar. So first of all, we will write the truth table of D. Right. D is there. This is Qn. Okay. So you can have 0, 0, 0, 1, 1, 0. And 1, 1. This is the truth table of D. Now coming into Qn plus 1. What is Qn plus 1? Qn plus 1 is equal to D itself. So you can write 0, 0, 1, 1. From there I am going to find J and K. You can find J and K. So it is this is present state and next state. So 0 to 0 means 0, don't care. 1 to 1 means don't care, 0. 1 to 0 means it is reset, right? 1 to 0 means it is reset. So it is don't care 1. 0 to 1 means it is set. So it is 1, don't care. That is the JK flip-flop. Now I am going to find the for J in terms of D and Qn. J in terms of D and Qn. So J I am going to find. I am going to make a two-variable K-map. Two-variable K-map. That is okay. So anyway, here there is no Qn. So you can write D and Qn. So I will write this 0, 1, 0, 1. D bar, D, Qn bar, Qn. So 0, 1, 2, 3. So it is 0, 0. J is 0. 0, 1. J is don't care. 1, 0. J is 1. 1, 0. J is 1. 1, 1. J is don't care. 1, 1 means J is don't care. So here what you can get, you can club these two. If you are clubbing these two, what will you get? That is expression is D. That expression is D for J. So you can write J is equal to D. That is the first expression. Now coming into next one, that is expression for K. I'm going to write the expression for K. So I am drawing the K map, a two-variable K map. I'm going to do a two-variable K map. So I am having D and a Qn. That is 0, 1, 1, 0. So it is D, D. So 0, 1. So it is D bar, D, Qn bar, Qn. So 0, 1, 2, and 3. So it is 0, 0 is don't care. 0, 0, don't care. 0, 1, 1. 1, 0, don't care. 1, 1, 0. This 1, 1 it is 0. So you can club these two. Now you can club these two. So what is the expression? You can get K is equal to D bar. The expression is k is equal to d bar. Okay. Now if I am drawing the logic circuit or a clockwise circuit, we are having JK. We are having JK flip flop anyway with a clock. Okay. And J is and D is input. So J is D and K is D bar. Here I am having Qn and Qn bar, output and inverted output. Okay. So this is how we are converting JK to D flip flop. So in this lecture what we have done with the conversion of JK to SR flip flop, and we have found that J is equal to S and K is equal to R. Second one is JK to T flip flop. There also we have found J is equal to K is equal to T. Then in conversion of JK to D flip flop, we have found that J is equal to D and K is equal to T bar. So that is a conversion from JK to SR, T and D flip flop. Thank you. And in the next lecture we will see the conversion of D to JK, T and SR. Thank you.